All right, good morning, class. Thank you so much for joining today's class. We are going to be looking at chapter 11, switch security configuration. Switch security configuration. And after the class, I intend to give you guys an assignment. So let's go through it. The assignment is for you to do the configurations yourselves. So we're going to be looking at how to implement port security on switches, and then we'll explain how to configure DTP, dynamic trunking protocol, and then native VLAN, and how to mitigate VLAN attacks. We're also going to be explaining how to configure DHCP snooping and how to mitigate DHCP attacks as well. We're going to be explaining how to configure address resolution protocol inspection and to mitigate ARP attacks. And then finally, we'll also explain how to configure port fast and bridge protocol data unit guards to mitigate STP attacks. So that's what we're going to be looking at today. So let's start with implementing port security. Layer 2 attacks are some of the most easiest for hackers to deploy, but these threats can also be mitigated with some common layer 2 solutions. All switch ports, which are the interfaces, should be secured before the switch is deployed for production use. How a port is secured depends on its function. A simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. So navigate to each unused port and issue the Cisco iOS shutdown command if the port must be reactivated at a later time. It can be enabled with no shutdown command. So to configure a range of ports, just use the interface range command. So the point we are saying here is that once you have switches on your network and users can connect to these switches, just make sure that the ports that are free, they are disabled. All right. This is only to allow usable ports to be active. Now, the simplest and most effective method to present MAC address table overflow attack is to enable port security. And we discussed this MAC address table attack the other day. Okay, where the MAC address table will be flooded with the wrong MAC addresses, such that it will keep the system constantly broadcasting because it cannot find a match for the MAC address in the destination frame. Okay, so port security limits the number of valid MAC addresses allowed on a port, and it allows an administrator to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. So when a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of the secure MAC addresses that are manually configured or dynamically learned on the ports. So by limiting the number of permitted MAC addresses on port to one, port security can be used to control unauthorized access to the network. And how do you enable port security? First of all, you enter into the interface port, for instance, fast Ethernet 01, then you issue the command switch port security. All right. Then you now say switch port mode access, and then switch port security, then you end. All right. So we are saying here that note, trunk port security is beyond the scope of this course. So by default, layer 2 switch ports are set to dynamic auto. All right. That is trunking is on. That's why we see this here. Okay, so therefore, the example in the example, the port is configured with switch port mode as access. That is why we had to switch it port to access first. Then, if you do the show port security interface FA01, as you see here, it tells you whether port security is enabled on the switch or not. Okay, it tells you the status, whether the security that you have enabled. All right, because this is like the security that has been enabled. Then it tells you the violation. If that particular this thing is violated, this is the action that will take place. All right, and then it tells you the maximum number of MAC addresses that has been assigned to that particular port to connect. So if you have more than one, it's going to shut down the port automatically. So after port security is enabled, other port security specifiers can be configured. As you can see here, if you just say switch port security and you put a question mark, it lists the other things that you can do with that same command. You can put the agent, all right. You can put the MAC address, all right. You can put the maximum number of MAC addresses or source MAC addresses, and you can even put the violation. All right. Now, limiting and learning MAC addresses. So to set the maximum number of MAC address allowed on a port, we use this command. You enter the interface mode first. Then we say switch port security. Then the maximum. Maximum now is the number of MAC addresses, the number of end devices that you want to be connected to that particular port. All right. So then you say switch port security maximum. So we say the maximum number of secure MAC addresses that can be configured depends on the switch and the iOS. All right. In this example, you can have like 8,192. So a switch can be configured to learn about MAC addresses on a secure port in one of these three ways. Either manually configure it, or dynamically learn, or dynamically learn sticky. All right. So the manually configured, you are trying to say, okay, you use the switch port security and put in the MAC address. That means you are saying that you only want this MAC address to be connected to this port. Any other MAC address that is connected will not be allowed to transmit data. Okay. Then the dynamically learn, it says when a switch port security command is entered, the current source MAC address for the device connected to the port is automatically secured, but it is not added to the running configuration. If the switch is rebooted, the port will have to relearn the device MAC address. So the point we are making here, in this particular case, we are only limiting the number of MAC address, but that MAC address can be the MAC address of any device. So if today I plugged in my laptop on that particular port, then it takes that MAC address and then it doesn't take any other as long as the switch has not rebooted. But the moment that it boots, if I plug in another device again, it's going to take in the MAC address of that particular device. Then dynamically learn sticky, the administrator can enable the switch to dynamically learn the MAC address and stick them to the running config by using the following command. Okay, so if you do switch port security MAC address sticky, so saving the running configuration will commit the dynamically learn MAC address to the NVRAM. Okay, so that way it's going to pick that MAC address and then store it to the NVRAM. So this is the example that we have. For instance, the administrator can specify a maximum of 4 MAC addresses, manually configures one secure MAC address, and then configures the port to dynamically learn additional secure MAC addresses up to the 4 secured MAC address. So you see here we have switch port mode access after entering the interface port, switch port mode access, then switch port security. Switch port security is maximum of 4. Then switch port security MAC address, then I specify the MAC address. Then switch port security MAC address, then sticky. So you see I have done both static and dynamic. Okay, so I have done the two of them, and this is going to take it and store it in the MAC address in the NVRAM. So it's going to take in this MAC address that I have put. Additionally, it's going to take 3 other that I have assigned dynamically and store them. All right. So if you now say show port security and then for that particular interface, it will tell you, look at it, the maximum MAC address is what? 4. Total MAC address is 1 that we have currently configured. then the MAC address is 1, and then the least source MAC address VLAN, it now gives you. So this is how you do. So if you say show MAC address, show port security address, it's supposed to list all the MAC addresses that have been placed in for port security. Now, how about security aging? It can be used to set the aging time for static and dynamic secure addresses on a port. And two types of agents are supported: the absolute and the inactivity. Okay, so the absolute and the inactivity. So the secure address, the absolute is the secure address on the port are deleted after specified aging time, meaning that once it takes that MAC address that you have given it, it's going to store it and it's going to apply every security measure based on that MAC address. But it's going to be having a time countdown. So once that time you have given it elapsed, then it's going to now flush that particular MAC address. So the second type, that's the absolute. The second is the inactivity. The secure MAC address on the port are deleted if they are inactive for a particular period of time. All right. So that is the area of the aging. So the first is absolute, meaning that irrespective of the MAC address, whether it is active or not, whether it's transmitting or not, after a particular time frame, it's going to flush it. But on the inactivity, what it simply means is that once that particular MAC address is inactive for a particular period, it flushes it. So use the agent to remove source MAC addresses on a secure port without manually deleting it. And that is either for the absolute or for the inactivity. So use the switch port security agent command to enable or disable static aging for the secure port, or to set the aging time or type. All right. So this is the example. So if I come to the interface, switch port, then port security aging time, maybe 10 seconds. Then switch port security aging time inactivity, which means that if this particular port is inactive for 10 minutes or 10 seconds, then it's going to flush it from the table. All right. So if you do show port security interface fast Ethernet 01, it tells you the status, it tells you the violation mode, and then tells you the aging time, the aging type, tells you the maximum, and it gives you details about that. Now, we have different modes in port security. If the MAC address of a device attached to a port differs from the list of secure addresses, the violation mode now comes into play. So the violation mode is either to shut down the interface or to restrict that particular device from accessing anything, or to protect. Now, the shutdown is actually to put the interface off entirely. All right. The restrict, it says the port drops the packet with unknown source address until you remove a significant number of source MAC addresses to drop below the maximum value or increase the maximum value. So this mode causes the security violation counter to implement and generate a syslog message. Then they protect. This is the least secure of the violation modes. The port drops packet with unknown MAC address source address until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum. So, but there is no syslog messages that are sent. Okay. So that is for the mode. Now, ports in error disabled states. When a port is shut down and placed in an error disabled state, no traffic is sent or received on that particular port. A series of port security related messages display on the console, as you have seen here. All right. So you see, it tells you that there's error disabled state, and then it will tell you the violation error detected at the particular port. This is the particular port in which it is being implemented, and then it keeps bringing up the same It keeps bringing it up for you to know, and then it tells you that it's caused by this MAC address. Yeah. Then it also tells you that the state is put to down. That's the disabled state. All right. So uh, the administrator should determine what caused the security violation if an authorized device is connected to a secure port. The security threat is eliminated before re-enabling the port. All right. So that is what we have here. Look at it. Where is the violation mode shutdown? And then aging time absolute, security static aging is disabled, and then okay, all right, here this is the violation count to 1. Look at it here. That's why we say the output of the show port security command now shows that the port status as secure shutdown. The security violation counter increments by what? By 1. All right, so that is it. Then after configuring port security on a switch, check each interface to verify that the port security is set correctly, and check to secure that the static MAC address have been configured correctly as well. So to display port security settings for the switch, we use the show port security command. When we do show port security command, it will list the ports in which port security has been enabled, and then it will tell you the violation that has been there. All right. So I think to verify, you can, if you run either show run, it's going to give you the details about the port security. All right. That is what. So we have a packet tracer activity. And I want to do it, but I prefer to give you guys as homework, all right, to do it. So what I'm going to do is I'm going to split you guys into 2 groups. I'm going to split you guys into 2 groups, and then well, maybe I give you guys this each group to be able to do one of this particular activity, and then we'll get back. So we'll get to that. Now, mitigate VLAN attacks. Right? So a VLAN hopping attacks can be launched in one of 3 ways. Right? A VLAN hopping attack can be launched in one of 3 ways. The first one is spoofing DHCP messages from the attacking host to cause the switch to enter the trunking mode. Okay? From here, the attacker can send traffic tagged with the target VLAN, and the switch then delivers the packets to the destination. So introducing a rogue switch and enabling trunking is another way. Putting a rogue switch and then the trunking. So the attacker can then access all the VLANs on the victim switch from the rogue switch. Then another type of VLAN hopping attack is a double tagging. All right, and this attack takes advantage of the way hardware on most switches operates. So how do you mitigate? First, you disable auto trunking, dynamic trunking protocol. You disable DTP negotiations on non-trunking ports by the switch port mode access. Okay, so configuration commands. So if you, that's step 1. Step 2, disable unused ports and put them in an unused VLAN. Okay, and then 3, manually enable the trunk link on the trunking protocol by using the switch port mode trunk command. Right, and then the 4th you can do is disable the auto trunking negotiations on trunking ports by using the switch port non-negotiate command. Okay, so disable it. Then number 5, you set the native VLAN to a VLAN other than 1 by using the switch port trunk native VLAN, then the VLAN number. Right? So these are like some 5 things you can do to mitigate or protect your switches from attacks, VLAN attacks. How about DHCP attacks? The goal of DHCP attacks is to starve the users from getting DHCPs, and they use tools like Gobbler to create a denial of service for connecting clients. All right. So the Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet address in the DHCP payload. So this would render port security ineffective because the source MAC address would be legitimate. Okay. Then you have DHCP snooping, which filters DHCP messages and rate limits. Rate limits DHCP. Okay. So, as we are saying, the idea of the DHCP snooping, we said device under administrative control such as switches, routers, and servers are trusted sources. Okay, so trusted interfaces like trunk links and server ports must be explicitly configured as trusted. Then devices outside the network and all access points are generally treated as untrusted sources. Okay, this is how you can, some of the things you can do to mitigate against DHCP snooping. Okay, then a DHCP table is built that includes the source MAC address of a device on an untrusted port and the IP address assigned by the DHCP server to that particular device. So the MAC address and the IP addresses are bound together. Therefore, this table is called the DHCP snooping binding table. So these are how to implement it. First of all, you need to enable DHCP snooping by using this command, IP DHCP snooping in the global mode. Then on the trusted ports, you use the IP DHCP snooping trust interface configuration mode command. Then on untrusted interfaces, you limit the number of DHCP discovery messages that can be received using the IP DHCP snooping command. All right. Then you enable DHCP snooping by VLAN or by range of VLANs by using the IP DHCP snooping, then the VLAN number, all in the global configuration mode. So this is an example. In the global mode, you just use IP DHCP snooping. Once you do this, you have enabled it generally on the global mode. Then you now go to the interface you want to apply. Then, for instance, fast Ethernet 0/1, which is this one in this case. Then you say DHCP snooping trust. You are trusting this link, this interface to this particular server. And then you come to this particular interface, all right, and then you limit the snooping limit, all right, by using this command. Then that is all. Then if you want the VLANs, then you can now say IP DHCP snooping VLANs 5, 10. You know you are specifying the VLANs. That way, there will be no, it will be difficult for a rogue VLAN to come in or on a different particular port connecting to that server. Okay. So if you do the show IP DHCP snooping, it will give you the details here. The interface that is being applied, whether it's trusted or not, okay, and then it gives you the number of packets per second. Then it gives you this interface, whether it's trusted or not, and the number of packets and things like that. So it gives you, but if you do DHCP binding, it tells you this is the MAC address and then the IP address, and then it gives you the release time and then the details there. Then we look at how to mitigate ARP attacks. ARP attacks are address resolution protocol attacks. An address resolution protocol basically applies on a switch where you want to map a particular MAC address to a particular IP address. Okay, so in a typical ARP attack, a threat actor can send an unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. So it maps it And to prevent ARP snooping and resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. Okay, so dynamic ARP inspections (DAI) requires DHCP snooping and helps prevent the ARP attacks by not relaying invalid or gratuitous ARP replies, or intercepting all ARP requests and replies on untrusted ports, and then verifying each intercepted packet for a valid IP to mark address binding. So you see, as we said, if an attacker wants to attack the switch using ARP attacks, it just gives the wrong information, either for the MAC address or the IP address. Because the idea is a frame comes in and says, hey, I have the MAC address of this particular, but I don't know the IP address. All right. And then it gives him, the IP gives him, or I have the IP address, I need to know the MAC address. And then it gives him, and then it maps the two. That is basically ARP. Okay. So to mitigate the chances of ARP spoofing and ARP poisoning, allow the DI implementation guidelines. That means you enable the DHCP spoofing globally. You enable the DHCP spoofing on selected VLANs that we have talked about, and you enable the DI on selected VLANs, and then configure trusted interface for DHCP snooping and ARP inspection. So it is generally advisable to configure all access switch ports as trusted and to configure all uplink ports that are connected to each other as trusted as well. Okay? So I do this and I say IP DHCP snooping for VLAN 10 and then ARP inspection VLAN 10. Then I come to the IP, the physical port interface, and then I trust that particular interface, and then the ARP inspection is also trusted. So DAI can also be configured to check both destination and source MAC and IP addresses. All right. So it's another feature that it has. So what happens if somebody validates or violates it? Now, the IP ARP inspection validate command is used to configure the DI to drop ARP packets when the IP addresses are invalid. Okay, so it uses this to validate it or to check whether it's valid or not, whether to drop it or to allow it. And this is the command we use on the global mode. IP ARP inspection validate. Okay, once you validate, then you tell it either the MAC address you want to validate, that's the destination MAC address you want to validate, or the IP address you want to validate, or the source MAC address you want to validate. So if any frame that comes in and does not meet the validation requirement, it's just going to drop it automatically. Okay. So therefore, entering multiple IP ARP instruction validate commands overrides the previous commands. So to include more than one violation method, enter them on the same command line as you have seen here. All right, so I have my source, destination, and then IP. Okay. So how do you mitigate spanning tree STP attacks? So recall that network attacks can manipulate the spanning tree protocol to conduct an attack by spoofing the root bridge and changing the topology of a network. So to mitigate STP attack, use the port fast and bridge protocol data unit guard. All right. Port fast immediately brings a port to the forwarding state from the blocking state, bypassing the listening and learning states. So apply to all end user access ports. Okay. But if that port is used for PoE, then you don't need to do that, because if that port is for PoE and you use port fast, it's not going to work. So the PoE is not going to work, sorry. The bridge protocol data unit guard immediately error disables a port that receives a BPDU. So like port fast, BBD guard should only be configured on interfaces attached to end devices. All right. So port fast and BBDU is applied to end devices. So how do you configure port fast? You enter the interface port, then switch port mode access, then spanning tree, then you type port fast. Okay, spanning tree port fast. So port fast bypasses the spanning tree listening and learning state to minimize the time that access ports wait for STP to converge. So only enable port fast on access ports. So port fast on inter-switch links can create a spanning tree loop. Yeah. So port fast can also be enabled on this as I've shown you. All right. So now on the globally, use the spanning tree port fast default global configuration command to enable port fast on all access ports. Okay. So here you do it when you want to specify it on a particular port. Here you want to do it on all access ports. Okay, but it's important that you know that it's only for access ports. All right. So to verify whether port fast is enabled, just use the show spanning tree within span command or show spanning tree summary command, and then it's going to show you, as you can see here, show spanning tree, and then it's supposed to show you the port fast. Look at it. Port fast default is enabled. It tells you whether the port fast for each protocol data unit is enabled or not. Okay. So that is that about that for today's class. Now we have two packet tracer activities. So I'm going to group you guys to take this particular packet tracer activities. All right, there are 6 of you, so I'll group you in trees. Okay, I'll group you in trees. So from the bottom, Mr. Tedo, and then Rofinwa and Mohammed are going to be in one group, and Mr. Tedo will lead the group for the configuration of that, and I'm going to tell you which packet tracer you're going to do. Okay, then Daniel, Akwanya, Elizabeth, Mawe, and Mokerese, you are going to be on another group, and then Elizabeth, Maui, you are going to lead that particular